Today we are going to talk about the Markovnikov and anti-Markovnikov rule. So before I start, I will give the hint in Hindi. Okay, Markovnikov MR. Okay, हमें कितनी बार मरना पड़ता है? How many times we are?
क्या?
How many times we are dying? Two times.
वन.
No, two times. एक नॉर्मल मौत और दूसरी शादी होने के बाद. ठीक है. Just remember Markovnikov rule is two. Okay, this is funny way to remember this. And anti-Markovnikov AMR. अमर कितनी बार होना है हमें? सिर्फ एक बार.
एक.
So remember Markovnikov 2 number and anti-Markovnikov number 1. Please remember this because this is a trick. So here we go and let's deep dive into this notes as well as the theory I'm going to share with you. So just 1 second, let me zoom it out. Okay, here we go. The when you talk about the Markovnikov rule, let's do the theory first. So here we go. My voice is very much clear, crisp and clear.
यस.
Okay. So what is the definition? Markovnikov means what I told you. Something is getting added on second degree. Please remember this. Okay. So when an unsymmetrical reagent like HX, what is HX? HI, HCl, HBr. Okay. What are they? They are unsymmetrical reagent. X means halogen. X means what?
हेलोजन.
The halogen. Okay. So what happened when unsymmetrical alkene is there? Unsymmetrical alkene means, for example, you have C double bond CH and here is CH3. Okay. 1, 2, 3. And it has to be 4, right? Okay. So now you need to add HI. So now the question is that will hydrogen goes here or hydrogen goes here? That is the question. Iodine will goes here or iodine will go here. So that is an unsymmetrical alkene. But if the same thing is given in a symmetrical way, for example, CH2 double bond CH2, so there will be no problem. Yes or no? Because I will get CH here, CH2 here. So it will be one H hydrogen and one here will be I hydrogen. I mean, I will be added. So there is no problem with a symmetrical one. Problem is with a symmetrical one. So for that, we have a Markovnikov rule. So definition says that when unsymmetrical reagent is added to unsymmetrical alkene, the negative part, see, when you have HX, when it dissociated from H plus and H minus, so which is the negative part? X minus, that is your halogen of the reagent attaches to the carbon having a fewer hydrogen atom. What we are talking about, it will goes to the carbon having to the fewer hydrogen atom.
लोअर्स.
Then so can you see that hydrogen is here less, so this X part will move here as per the definition. This point is very much clear. Okay. And the while positive part attached to the carbon having the more hydrogen, so hydrogen moves here. So as per the rule, iodine will be going here where we have a less hydrogen and your this hydrogen will go here where is a high hydrogen. So what you understood that, don't you think too it is a second position always? Second degree carbon. Now you got it. What is the trick? Second. Yes, that is a trick. Okay, so reach get reacher. What do you mean by reach get reacher? Already
एक मिनट.
hydrogen.
हाइड्रोजन सबसे ज्यादा CH3 के पास है ना?
हाँ लेकिन यहाँ पे तो ऐड नहीं होगा बिकॉज इसकी तो कैपेसिटी खत्म हो गई है बच्चा. इसके पास कोई
ओके.
मतलब नहीं है ना, इसका कोई मतलब नहीं है. खाते पीते घर का है. प्रॉब्लम किसको है? इन लोगों को है. उनको चाहिए बाबा क्योंकि डबल बॉन्ड है, डबल बॉन्ड हैज टू बी ब्रेक और कोई तो ज्वाइन करेंगे ना, दैट इज द रीजन. सो हाइड्रोजन गोज टू द कार्बन ऑलरेडी हैविंग मोर हाइड्रोजन, like attract like this. Got it now? Yes. So what is the general reaction of Markovnikov rule? CH2CHR, the way we have discussed, right? HX, H will go to already this hydrogen, it becomes CH3 because reach get richer. And this X will be attached to this part. Yes or no? Now you point is very much clear. Can you count here 1 or 2 seconds? Again, the second degree carbon. Yes or no? Okay. Okay. Now you got it. Where
हाँ.
where is the more hydrogen? The hydrogen will always goes there. Okay. Okay. Now
Hmm.
let's talk about its mechanism. It is electrophilic addition. What is electrophilic addition? X was there. It become H plus and X minus. This X minus is called electrophile. What is electrophile? Electron loving. Like X represent your chlorine, bromine, iodine. These are the halogens. And halogens need anyhow one electron. Mostly, yes or no? In case of chlorine, they need one electron to
Hmm.
get stabilized. So these are the electrophile, and this electrophile is getting add to what? Double bond. That's why electrophilic addition is there. This point is very much clear.
Hmm.
Okay, so first H plus attacks on the double bond, formation of carbocation. So for example, this double bond is there. Okay, and now you have H plus and X minus. So the H plus will attack on this part, and this form the carbocation. Cations means positive charge,
Positive.
because positive is attached. I mean hydrogen is getting attached over there. Okay, and then because of this positive attack, definitely this will be, यहाँ का भी बॉन्ड टूट जाएगा ना, यहाँ का भी बॉन्ड टूट जाएगा, तो यहाँ पे कौन
Hmm.
अटैक करेगा? हैलोजन विल बी
X
अटैक.
minus.
तो एक्स halide अटैक द कार्बोकटायन, फॉर्म्स अ मेजर प्रोडक्ट. ओके गॉट इट. ये कहाँ अटैक करेगा? मेजर. जैसे ही पहले कौन अटैक करेगा? हाइड्रोजन. और क्या बनाएगा? कार्बोकटायन. और कार्बोकटायन क्या है? पॉजिटिव चार्ज है. इलेक्ट्रोफाइल कौन सा चार्ज है? नेगेटिव चार्ज है. तो दोनों के ऊपर क्या हो जाएगा? अट्रैक्शन हो जाएगा. तो इलेक्ट्रोफाइल मतलब एनी हाउ इट वांट दी इलेक्ट्रॉन. This point is very much clear. What is the reason?
Hmm.
What is the reason? The reaction proceeds to the formation of the most stable carbocation. That is why it's always attack on the secondary carbon. Okay. So tertiary, secondary, and primary. So what is tertiary carbon? Tertiary carbon having this, okay, attachment. Secondary carbon having this attachment, and primary carbon only one attachment. Getting my point?
Hmm.
Okay. So who is more stable? Tertiary one, secondary one, and primary one. Okay, that is the reason. Which is this electrophile addition? Now let's take one example at the time. Let's get one example. So let's have the addition of HBr to propene. Okay, I want more space. So I'm having a more space over here. So what we have? We have a CH3, CH, now double bond CH2. Okay. Now who is getting added? HBr plus HBr. Definitely, which rule are we doing? We're doing Markovnikov rule, MR. So during the MR, definitely, now tell me, this hydrogen will be attacked first, H plus and Br minus will be there. Let me show you here. What form? H plus and Br minus, yes or no?
BM. Hmm.
Now, can you tell me this H plus is going to attack here or here?
CH3.
CH3? No, 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 no. Only this much
नहीं
part
अच्छा
will
नहीं
get
नहीं CH2 CH2
CH2.
CH2.
Yes, yes, exactly.
हाँ.
So this H plus going to attack over here. What going to form? Carbocation. And once the carbocation form, who will be following back? Br will be there.
BN.
Okay. So we are directly drawing or giving you the last product. Okay. So what going to happen? CH3 will be as it is. CH will be attacked by Br, and this becomes CH3. Yes
Single
or no?
bond CH3.
Yes,
Hmm.
again, one, two, or three. Can you see that on second carbon mostly this is attached? So this is a this is a Markovnikov rule. This is what? Markovnikov rule. Can you read the step one and step two for me? Step one.
H plus adds to the carbon having more H atoms. It forms a secondary carbocation.
Okay, now wait. Now, shall I show you that? I will show you that. CH3, CH. This will be CH3, and this will be your carbocation. Are you getting my point? This is the carbocation having the positive charge over here. So this will be attacked now. Got it? Yes,
Hmm.
this point is very much clear to you. Here we go to the next thing. Now let's have the next reaction. What is the next reaction? Okay, this is the reaction. Can you see that? Same. Sorry, this is the same thing. Can you see that? It is attached on the middle. So this is a major
Hmm.
product. So what is the name of this? 2-bromopropane.
Bromopropane.
And the second carbon is attached. Well done. Now let's go to the next one. So here we go. So what is this? We have a bute. Let's draw it. Bute 1-ene. Can you help me out how to draw this? Bute means 1, 2, 3, 4. 1-ene, that means I'm counting from here. So this
Hmm.
will be CH3. This will be your CH3.
CH2.
No, it will be CH2. Very
CH.
good, because it is middle. Very good. And this is your CH2, and this will be your CH, right?
CH.
Yes.
Hmm.
Now what we are adding here, we are adding the HCl. Again, the same thing. Give me the direct product. Tell me.
CH3, CH2, single bond, C.
Should I
No.
attack here? Cl will be attached here, right?
Huh.
So
Hmm.
bute 1-ene. Now what form? What is the bute 1-ene? Now its form 1, 2, 3, 4. 2 chloro
Fluoro. Propane.
butane.
Butane, butane.
We have still 4 carbon attached, right? No carbon is removed
Hmm.
off. Okay, that is the reason. This point is very much clear.
Hmm.
So what is the conclusion? Markovnikov rule says that hydrogen attached to the carbon already rich in hydrogen, right?
Hmm.
Rich. Or I told you the rule, second carbon always. Okay,
Hmm.
this point is very much clear. Now let's move to the anti-Markovnikov rule. But what is anti-Markovnikov rule? Opposite. How many times we are going to become Amar?
One.
1. So primary, it attach on the primary carbon. Okay, please remember this trick. So in presence of peroxide, what is peroxide? A strong one. Yes or no? In presence,
Hmm.
otherwise it will be follow Markovnikov rule. But in presence, for example, right now we are talking. Suppose your parent is there in front of you, so definitely you will be very focused. The moment the parent move
Hmm.
off from the room, you will be relaxed. Yes, I'm not saying you are not studying. I'm saying you will be relaxed, right? So you will get activated in
Hmm.
presence of something. So in case of peroxide, HBr getting activated. So they attack in a very different manner. So HBr adds, only HBr will be follow this rule. Please pay attention. HBr adds to the unsymmetrical alkene in opposite orientation to the Markovnikov rule. That means Br atom reaches not to hydrogen. Now it goes to the हाइड्रोजन जहां सबसे
Carbon.
कम रहेंगे वहां उस कार्बन पे जाएगा वो है ना.
Hmm.
Yes. So what is the conclusion? Reagent is HBr. Always remember anti-Markovnikov rule. Reagent is what? Your HBr. Catalyst peroxide. Catalyst. What is catalyst? Who speed up the reaction? Or here, who makes the reaction to HBr get attack first on the primary carbon, first carbon. Okay. Then mechanism is free radical. What is a free radical? Free radical means, for example, Cl and Cl bond are formed because of the light energy. They got homolytically cleavage. So Cl will get his electron, Cl will get his electron. So they are what? Do you remember where we have learned this? We learned
Hmm.
this in a UV radiation under
Alkene
the sun.
part.
Yes, alkane part. So that is a radical over there, right? Free radical attached. And only with HBr is your anti-Markovnikov
Hmm.
rule is going on. This point is very much clear.
Hmm.
Yes. Okay, bacha. Now, let's have the general reaction. What is the general reaction? CH2 double bond CH, and this is R. Let's take this as CH3. Okay, we don't have to worry about this. That is R right here. Correct? Now,
Hmm.
what should I add? I should add the HBr.
Yeah.
But the moment I add HBr in presence of peroxide. Okay. So ideally it
Hmm.
should goes here. No, it's sorry. Ideally it goes here, right? CH2. Yes or no?
Hmm.
H should go here. But because of the peroxide, it is moving. This H is moving to this part. Okay. Because already
Hmm.
less hydrogens are there. It's moving to this part. Okay. So what is the product going to form? Your CH here will be attached your Br, right? And here will be your CH2 and this is CH3. So can you say that on primary 1, 2 or 3? This is what? 1
Primary.
bromo propane.
Propane.
So can you
Hmm.
see that on first carbon it got attached? So this is your Markovnikov? No, it is anti-Markovnikov rule. So addition of HBr to the propane in the presence of peroxide. These are the peroxide. Okay. This point is very much
Hmm.
clear. Okay. So we'll got this thing. So major product will be your 1 bromopropane. Yeah, you will get 2 bromopropane, but that is not sufficiently countable. Okay. Now let's go for the this example. I will need a space little to write this. So addition of HBr, but 1-ene. Tell me what is but 1-ene. So the
Four
moment
carbon.
yes, already that is given, right? CH2 double
Hmm.
bond, CH, CH2,
Yes, two
CH3.
CS3.
Now, okay, my mistake. Let
Hmm.
me do erase it. 1 second, I'm erasing it. Okay, what should I write in here?
Plus HBr.
HBr. Should I write HCl and peroxide together? No, because only HBr is responsible for giving this anti-Markovnikov. So the H will be attacking on the less carbon.
CH.
So carbocation again form. So CH, tell me what is that? CH2 here will be attached Br. Yes or no? Br will be attacking on this first one, right? So your
Hmm.
CH2, CH2, CH3. What is the compound name? 1 bromo butane.
Okay.
Butane,
Butene.
butane. This point is very much clear. Yes or no?
Hmm.
So we have done anti-Markovnikov rule only in presence of peroxide and only with HBr this is going to happen. This point is very much clear. Okay.
Hmm.
And mechanism, let's understand the mechanism. So first mechanism is ROR. What is ROR? This is your peroxide. For example, CH3. CH3O, C, this is OCH3. This is what homolytic fission is going to happen. So your CH3O radical is formed. Can you see that dot is what? The radical is formed. The moment the radical is formed, this radical is going to attack on HBr. As it's going to attack on HBr, what will be formation? This CHO3, this is O is there. Definitely will take snatch the hydrogen. Yes or no? So it will be snatched CH3OH will be formed and your Br will be now the radical, free radical. This point is very much clear. So this is
Hmm.
the initial or initiation. This is a initiation. This point is very much clear. Okay.
Hmm.
Now there will be a propagation. What is propagation? Now Br, which is formed, that is a free radical. Yes or no? It's going to
Hmm.
attack on your what? Attack on what? Tell me. Attack on
Propene.
alkene, unsymmetrical,
Hmm.
unsymmetrical alkene, right? It's going to attach on unsymmetrical alkene. Now the moment is going to attack, definitely what going to happen? Can you see that? The Br is getting attached to the last one because it forced to attach there. So what is forming CH3? CH. But here will be a dot. Why there is a dot? Because it is a formation of
Free
cation,
radical.
radical. The radical is Br.
Hmm.
Radical means what? Br or this. This is also this is cation. Why? Because they have the charge, because the bond is broken down, but still there is a gap, electron needed, right? So
Hmm.
now you can see that the again if the HBr come into the picture, ideally Br should be attached, but already Br is there. So who will be going there in this position? Hydrogen is going to there. So this becomes CH3, CH2, CH2, Br, and hence the Br is attached on the primary carbon. Yes or no? The first carbon.
Hmm.
Okay, and what is the termination? Termination, two radical combine to stop the reaction. So CH3O2 or this HBr, they will be form a bond to form again the same. This will be form HBr. This will be form CH3O CH3. Again, the same thing is happened. This one is very much clear. This mechanism you should not aware about in very much detailed manner, but are you understood this thing? This is more similar to your chlorination. Yes or no? Chlorination once happen, it's keep on happening. Yes or no?
Hmm.
Right. So what is the important note and comparison here? Let's understand that. The peroxide effect is also only with HBr, and that is called as anti-Markovnikov rule. HCl bond is too strong to break, okay, because it won't form, and HI forms I2 rapidly, so no effect. So if the MCQ come or the question comes, why it is only formed in HBr? Because HBr is ready to form free radical. But in case of HCl, it's strongly bonded by acid is there, right? And HI,
Hmm.
iodine is continuously formed, so there is no impact. So without peroxide is a Markovnikov rule. With peroxide is anti-Markovnikov rule. Okay, Markovnikov it is ionic, and with peroxide a free radical mechanism is there. So this is how we have done the Markovnikov and anti-Markovnikov rule, right? Okay, so right now we are solving some worksheet to understand have we done this properly? This concept is very much clear or not? So here we go to understand the sheet. Okay, so Kavya, you're going to help me for the same thing. So here are some reactions and we have to complete it. So first they have given you what they given you? CH2 CH2. It is a symmetrical or asymmetrical? Mm-hmm.
Symmetrical? नहीं.
Symmetrical.
Asymmetrical.
Because only two carbons are there. There is no chance at all of unsymmetry. So it is very easy.
Hmm.
If you add H here or here, there is no problem, right? Why there is no
Hmm.
problem? Because it is a symmetrical. So can I write this CH2? I can write Br over here or CH3. No issue because it is a symmetrical one, right? Okay. But now the
Hmm.
problem persists because this is unsymmetrical one. So which rule, if nothing is given, so which rule you follow? Markovnikov rule. Markovnikov rule says that richer become more richer, or two
Hmm.
times we have to die. So secondary carbon. So first, second, and third. Even first, second, and third. Anyhow you count, the middle one is the second one. So CH3, CH, your Br will be attached
Okay.
and here will be your CH3. Yes, point is very much clear.
Hmm.
Well done. Now let's go. Now there is a peroxide they have given. The moment they give you peroxide, it becomes anti-Markovnikov rule. Anti-Markovnikov rule states that how many more times we become Amar? Only one time.
One.
So what will be the product? CH3. CH. Here will be CH2, right? Because hydrogen will be attached. And this CH2 will be having the Br, right? Yes.
हाँ.
Now, your turn. Tell me. This is Markovnikov rule because nothing is given. So, what is your answer for this? See, only this part. Consider this part. Don't consider this part. CH2, CH, CH2, CH3 as
CH.
it is. Where are you going to attach? Definitely here. Cl will be attached here.
Hmm.
And here will be CH3, right?
CH3. Hmm.
Yes. Well done. Now, the E in presence of peroxide. It become now anti-Markovnikov rule. Tell me, what should I write? I'm just writing the thing.
Hmm.
CH2, CH, CH2, CH3. Tell me where should I attach? I will attach. We are here, bacha. And here will be CH2 because it is anti-Markovnikov rule, right?
Hmm.
Okay. Okay. Let's solve the G1. Tell me the direct answer.
CH3.
If you have doubt,
Single.
we have a and following anti-Markovnikov rule. Now, how many times we are dying? One time.
One.
बट अमर सॉरी अमर एक टाइम, मरना कितनी बार है? दो
Two.
बार मरना है. सो
हाँ.
अभी मुझे बोलो यहाँ पे अभी गड़बड़ क्या है कि सिमेट्रिकल है ना? दिस इज अ
Hmm.
सिमेट्रिकल. नाउ नाउ ये सिमेट्रिकल है. अगर ये सिमेट्रिकल है तो अभी आप कौन से भी कार्बन पे ऐड करो, इट डजेंट मैटर राइट नाउ. यस और नो? क्योंकि ये कौन है?
Hmm.
सिमेट्रिकल है. सिमेट्रिकल में पता ही नहीं चलेगा यहाँ से है कि यहाँ से है, तो आप कहीं से भी ऐड कर सकते हो. देयर इज नो इश्यू एट ऑल. ओके. बट अगर वही एच देखोगे एच, पहले ये सॉल्व करते हैं. क्या आ जाएगा आपका? CH2 I यहाँ पे आ जाएगा. यस और नो? CH. लेकिन नहीं, रुको रुको रुको, यहाँ पे गड़बड़ है. क्या गड़बड़ है सर? ये रिएक्शन होगा ही नहीं. है ना? नो रिएक्शन, नो रिएक्शन। क्यों नो रिएक्शन?
एच
पेरोक्साइड
आई।
से, हाँ इसमें होता ही नहीं है। ये भी नो रिएक्शन, यस और नो? है ना?
हम्म।
नहीं होगा, क्योंकि क्या है, HCl HBr हमने पढ़ा था, तो वेल डन। ऐसे ही आग बंद करके नहीं करना, ये भी चीज करनी है। चलो ये लास्ट वाला करते हैं, अनसिमेट्रिकल वाला। इसमें क्या आएगा? CH3, CH2। डेफिनेटली यहाँ पे आएगा आपका Br। बट यहाँ पे क्या लिखा है? सुनो 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 सुनो, देखो हमें
नो
उल्लू बनाया, फिर
पेरोक्साइड।
से उल्लू बनाया हमको। हमको उल्लू बनाया गया है। क्या लिखा है? नो पेरोक्साइड। तो कौन सा रूल फॉलो करेंगे हम? MR रूल फॉलो करेंगे। तो यहाँ पे अटैच होगा HBr और यहाँ पे अटैच होगा CH। गॉट इट?
हम्म।
So this is how we have done Markovnikov and anti-Markovnikov rule. It is simplified now, very much simplified, बच्चा।
हम्म।
Okay.